to L. So we can write R directly proportional to L. And this is the statement is from your science, that is physics. And after this, your mathematics will work a lot here. Whenever you get one quantity is directly proportional to another quantity, you can write 5 applications, right? So I can write this one generalization, R2 by R1 is equal to L2 by L1. And the second application, simply by taking this one denominator to the right hand side, I can write R2 equal to R1 times L2 by L1. And the third application simply change, so delta R equal to R1 as it is here, you will get minus 1 extra. And now fractional change, simply this L1, this R1 is taken to the left hand side, that's it. First case R1 is taken to the right hand side, and from third onwards R1 is taken to the left hand side. So you will be getting delta R by R1 equal to L2 by L1 minus 1. And now finally, percentage change, just to fractional change into 100 is the percentage change. Okay, I hope you understand. And let me give you a practical question which was asked in the previous examination. Dear students, do you want to know the power of mathematics? Today, let us discuss about a simple technique which can make you to achieve your IIT, to achieve your medical entrance exam, to crack any entrance exam which you may write after your class 12. And this is going to be your the best session for foundation level preparation. Dear students, you might have neglected your mathematics during 5th, 6th or 7th standard. Now, in this session, I am going to show you the power of simple techniques involved in algebra at 6th, 7th standard, which can help you a lot cracking entrance examination. Let us discuss a simple technique today, proportions and variations. Usually, proportion means what? Proportion means correspondingly increasing or decreasing. And variation is the same meaning. Now, proportions and variations, we have two concepts, direct proportion and inverse proportion. So first let us discuss about the direct proportion today. Direct proportion means when a quantity increases, correspondingly another quantity also increases. Inverse proportion means whenever a quantity increases, correspondingly another quantity decreases. Here, this second quantity is varying direct with first quantity. As first quantity increase, second quantity also increase. Here in this case, the second quantity varies inversely. As it increases, it is decreases. If this decrease, this increase. So this kind of the variation or proportion is called direct proportion, and this kind of variation is called inverse proportion. Today, let us discuss about the two topics, two concepts and applications. First, let us start with the direct proportion. Here, direct proportion means, I told you already, when a quantity increases, correspondingly another quantity increases. And let me consider two quantities here, A and B. And here, A depends on B. That means, as per the variation in B, there will be variation in A. When B increases, A increases. When B decreases, A decreases. So I can say here B is the independent quantity. And here A depends on B. So A is called as the dependent quantity. As A directly depends on B, that means A is varying directly as B. So I can write this as mathematically A is directly proportional to B. And this is the direct proportional symbol, dependency symbol. And I can write this one and I can read this one, A depends on B or A directly proportional to B. And here B is the independent quantity and A is the dependent quantity. Now, I can write here A directly proportional to B, and in your basic mathematics algebra, whenever A directly proportional to B, we can write A is equal to certain constant times B. And this constant, I can take this constant anything like C or anything like K, or it might be like your favorite variable, but the usual notation is this constant usually assumed as K. And let me write down the equation now. So I can write A equal to this constant K times B. And this is equation which results due to the direct proportion here. And let me consider in our own language, let me give you an idea. Suppose, and I told you already, this is independent, right? And this is the independent quantity. As this is the independent quantity, I need to choose B value. And I need to give that input B value. So let B equal to B1. Okay. And if B equal to B1, definitely A also equal to A1. Correspondingly, A becomes A1. So that A1 equal to, what is A value? K times B. And K times, what is B value? B1. So A1 give you K times B1. And similarly, if I substitute B equal to B2, I can get A2 equal to K times B2. Very simple idea. There is no complexity in this one. Direct substitution. Suppose instead of B1, B2, if I give you B equal to 5, then A is going to be, we know very well what is A. A equal to K times B. So I can write here A equal to K times B value 5. So A equal to K5. Suppose if I give B value 50, then A equal to, you can guess here. It is very easy. A equal to K times 50. And this is the idea behind a direct proportion. So, and let us generalize the discussion. Instead of giving B value something else, let me give you generally B equal to X. So I can get here, you can understand now and you can guess easily, A equal to K times X. And till now we have discussed for individual inputs what is the output. That is, what is the value of A for each individual value of the B. Now let us compare for two different inputs. Suppose if I take this one, initial B equal to B1, so A1 equal to K times B1 and B equal to B2, A2 equal to K times B2. Suppose I want to compare the second time value, that is A2 with A1, comparison of A2 with A1. And in basic mathematics, comparison means ratio. You should take the ratio. Always remember, comparison of one quantity with another quantity. With what quantity you are comparing? You should take it that as a denominator. And the quantity which you are taking for comparison, that is numerator. Now here, I want to compare A2 with A1. So I need to take A2 numerator and A1 as denominator. So A2 by A1 equal to, what is A2 value? K times B2. So K times B2. What is A1 value? K times B1. So K times B1. And it is very clear that here numerator and denominator we have the common term K. So that can be cancelled here. K and K cancelled. Now what are you left with? A2 by A1 equal to B2 by B1. If you compare A2 with A1, you can write A2 by A1 equal to B2 by B1. Suppose your requirement might be different. You may need comparison of A1 with A2. So that also you can write A1 with A2. This time B1 with B2. If you compare the output, correspondingly inputs also compared. Clear? Suppose instead of 1 and 2, if you take some other arbitrary, let us say A3 with A4, you can get B3 with B4. So this is the result of comparison of a quantities involved direct proportion, and this is going to be your first application of the direct proportions, that is A2 by A1 equal to B2 by B1. Suppose if I get an idea like the simplification, next level mathematical operation here, suppose A1 is taken to the right hand side, as this is in denominator, as per the transpose method, this is division operation, so it must be involving multiplication operation on other side. So now A2 equal to A1 times B2 by B1. So now I can write this one as A2 equal to A1 times B2 by B1. And suppose next, this is called second level application. This is first level application and this is second level application. And now the third level application, I know what is the new value because of the new value in the B. but I want to know what is the variation. Variation means change. Suppose I want to change of A from second value to first value. So A2 minus A1. And I know that what is A2 value? A2 value is A1 times B2 by B1. So I can substitute this value here. Okay. And I can get here A2 delta A equal to, here A2 means A1 times B2 by B1 minus minus as it is and A1 as it is. Now if you observe this expression, here A1 is common in this term and A1 is common in this term. So in these two terms we have A1 common. If I take this A1 common, here I am left with B2 by B1, here I am left with A1 times 1 is by default. So I will be getting B2 by B1 as it is minus and this one as it is when you take A1 as a common term. And this is the third level application. Suppose I want to compare changes with the original quantity. How much change when compared to the original? And this will be helpful for you to estimate the loss or gain. Suppose if you get a 1 rupee loss for the investment of the 10 lakhs, how can you know whether it is serious loss or negligible loss? For the same 1 rupee loss, if you get for the investment 2 rupees, how can you know? When you compare the loss with the input investment. If you compare this loss, let us say 1 rupee loss is there, if you compare with the 2 rupees, that is really dangerous. When you invest 2 rupees, 1 rupee loss means. It is really a terrific, right, business, heavy loss. Suppose the same 1 rupee for the investment 10 lakhs rupees, it is negligible. How can you know this? When you compare whatever the change you got, when you compare this change with the original value A1, that is first quantity. Simple. So change in output is compared with the original output, initial output, then only you will come to know how severe it is and how benefit it is. And this is very important application. So next level is compare delta A with A1. And now the same expression let me take here. Here I got, till now I got the three application ideas. Now let me come to here. Delta A equal to A1 times B2 by B1 minus 1. If I compare delta A with A1, how to compare simply? Comparison, we need to take ratio. And same A1, right? And what do you get here? A1 cancelled. And you are left with delta A by A1 equal to, here A1 cancelled, so B2 by B1 minus 1. This is the fourth level application. Fractional change, we call this one. And next, we want to normalize, we want to standardize this discussion. Suppose if you get 1 rupee loss for 2 rupees, how much percentage? We will normalize to the 100 level, 100 parameter, that is called percentage. Simple, into 100. So the percentage change here is delta A by A1 times 100. What is delta A by A1? You know already this one. So percentage delta A can be written as B2 by B1 minus 1 times 100. And here you can even more simplification possible here. B1 is the LCM for this expression. So B2 minus B1 by B1. And B2 minus B1 can be written as delta B. This is the idea, simple. So if you want a percentage change in A, that is going to be equal to the percentage change in B. Right? Now, let me give you another idea. Suppose if you have A directly proportional to B, A equal to KB. And for this direct proportion, in physics or chemistry, in science, the possible applications and the possible questions from the examiner, possible application level questions. From this, the first application is, you can write A2 by A1 equal to B2 by B1. And the second level application, you take this A1 to the right hand side. That's it. So A2 equal to A1 times B2 by B1. And the next level application, A2 minus A1, that is delta A. That is equal to A1 as it is and B2 by B1 minus 1 in addition. And now, the next level application, we compare this change with the original. So this A1 will come this side, delta A by A1 equal to B2 by B1 minus 1. And the last application and the final application, percentage delta A equal to B2 by B1 minus 1 times 100. So whenever you get direct proportion concept, remember my dear students, You have to write all these applications by your own. Develop that strategy. So based on that expression, there are only 5 possible applications from the algebra for the direct proportion, direct variation concepts. Let me give you a simple example. The resistance of a conductor is directly proportional to length. So based on that simple concept, you can get only 5 kinds of the problems, 5 kinds of the application level problems in physics. Okay, let me give you that idea clearly. And before going further, let me give you an idea. It is not only b, if suppose b square is given, same thing you can write. Suppose if a is directly proportional to b square, you can write a equal to k times b square. This is also direct proportion but square. I can write a2 by a1 equal to, here this side you have b square, so I can write b2 square by b1 square. Same way here you can write in another way, b2 by b1 whole square I can write. Whole square I can write. Okay. And now same second application, a1 is taken to the right hand side, you will get this expression. And this expression I can write in another way, I told you already. Whenever the power is given, power can be written common. So a1 times b2 by b1 whole square, simple. And the next application is change. Change equal to original output a1 times b2 square by b1 square minus 1. Or you can write here b2 by b1 whole square minus 1. The square can be maintained common for both numerator and denominator. And similarly, you can get the fractional change, that is delta a by a1. And here also you can write the same. This square can be written directly here. Yes. And next percentage. Here also same. The square can be taken common. Okay. This is simple idea. Suppose instead of square, if I give you square root or cube root, or let us say power n. Yes. Square root can be written as power 1 by 2. Cube root can be taken as power 1 by 3. And anything can be made as the power, generalization. So if I give you a is directly proportional to b power n, I can write a equal to k times b power n. And what are the 5 possible applications of my dear students? This is going to change your problem solving strategy forever. Remember, for any direct proportion, you must be in a position to write these 5 applications by your own. The first application is comparison between second quantity and first quantity. So a2 by a1 equal to b2 by b1 whole power n you can write, or individually you can write. So b2 by b1 whole power n. And next, second quantity, this a1 is taken to the right hand side simply. So if you get the first one, you can get all. Simple, no need to by heart also. So first one how to write, you need to remember. Now a2 equal to a1 times, this one can be written as a1 times, I told you just now in the previous case also, a1 times b2 by b1 whole power n, b2 by b1 whole power n. And the same thing like delta a equal to a1 times b2 by b1 whole power n minus 1. Similarly, we can get the fractional change. Similarly, we can get the percentage change. Yes. And now, I hope you understand the direct proportion and variation concept and application level. Now, let us discuss 1 or 2 questions to get the command over this. Now, let us discuss simple application based on this. Just now I told you. Here, application is resistance of a conductor. Let me assume this is the conductor of length L and area of cross section A. And according to the Ohm's law, and after Ohm's law, discussion regarding the comparison or variation of the electric current with respect to the potential, and we know that resistance of a conductor directly proportional to L. So we can write R directly proportional to L. And this is the statement is from your science, that is physics. And after this, your mathematics will work a lot here. Whenever you get one quantity is directly proportional to another quantity, you can write 5 applications, right? So I can write this one generalization, R2 by R1 is equal to L2 by L1. And the second application, simply by taking this one denominator to the right hand side, I can write R2 equal to R1 times L2 by L1. And the third application simply change, so delta R equal to R1 as it is, here you will get minus 1 extra. And now fractional change, simply this L1, this R1 is taken to the left hand side, that's it. First case R1 is taken to the right hand side, and from third onwards R1 is taken to the left hand side. So you will be getting delta R by R1 equal to L2 by L1 minus 1. And now finally, percentage change, just fractional change into 100 is the percentage change. Okay, I hope you understand. And let me give you a practical question which was asked in the previous examination. So let us see how the questions were asked in the previous entrance examination. Just now you have understood the concept and application. Now let us see problem solving. Here the resistance of a wire is R. The statement is resistance of a wire is R. So this R is R1. If the length of the wire is doubled, that means length became double of the original one. Okay, then the new resistance will be, new resistance means second time resistance, R2 equal to how much? Simple. Here L1 became 2L1 and R1 became how much? That is R2. You need to find out. We know that the simple strategy here is, we know that here R is directly proportional to L. Okay, and we can write R2 by R1 is equal to L2 by L1. Simple. Substitute that only. So R2 divided by what is R1? R1 is R. So simple, R equal to what is L2? L2 is 2L1. So 2 times L1 divided by L1 as it is. And here L1 cancelled. So you are left with R2 equal to how much? 2R. Simple. Your first option. Right. This is Karnataka Common Entrance Test 1993 question. Yes. Suppose you may get a question in another way, like this one. This question was asked in CPMT 2000 and PBCET 2004. These kind of questions were asked in MSET also. Now, the resistance of a wire is 10 ohms. Yes, R1 equal to 10 ohms. It is given already. And if its length is increased by 10%, increased by, that means percentage of length is equal to 10%. The new resistance will be, what is the R2? That is the question. New resistance R2 equal to how much? And we know that percentage change in delta R is equal to, yes, delta R by R into 100. That is L2 by L1 times minus 1 into 100. That is delta L by L into 100. That is percentage delta L directly. And percentage delta is, we know that one, 10%. So delta R by R1 is 10 equal to 10%. I mean into 100 equal to 10%. If you take this 100, 10 by 100. And if you take this 10 into 10, you are going to get this one 1. And what is delta R? R2 minus R1 is 10, that equal to 1. So R2 is equal to 1 plus 10 equal to 11 ohms. And this is going to be your answer. Right? Very simple. Thank you all.